Good afternoon. First of all, thank you so much for having me here. Big thanks especially to Chris and Jenny and the other organizers and staff here at PyData Carolinas. Especially thanks for hosting this content that we're creating here together online. I actually spent about 8 years in Asia, and during that time, 4 of those years, I was getting an undergraduate degree, and online resources were an incredibly important part of that. So I'm grateful to all the content producers and to PyData for hosting all this great content online. So just a few quick notes before we get started. I may have tried to pack a little bit too much into this talk. If you had a look at what we're talking about today, there's a lot for us to get through. I have gone out of my way to try to make sure we can have a discussion at the end for about 5 minutes. But so that we get there, I just ask that if you have any questions, write them down, jot them down, and save them for the end. Or find me in the halls or online afterwards. And I'd love to talk to you guys about that stuff. So we'll break the talk up into 4 sections today. First section is just a couple of case studies. And we're looking at these case studies with the idea that Python gives us a tool set that allows us to build powerful toys over a weekend and powerful tools on the order of a few weeks or months. So we'll look at a few different tools that I built by composing the functionality of multiple libraries and look at kind of what goes into that. And then from there, we'll talk about some tools and strategies for interactively exploring APIs. So when you've got all these different libraries that you're working with, what are some tools that we have available, and what are some strategies that we can use for finding integration points and getting these libraries that often are maybe not immediately compatible to talk to each other. And then lastly, we'll talk about how to stand on the shoulders of giants without falling. We'll talk about some pitfalls and difficulties that can arise when we're taking powerful things and we're gluing them together quickly. And then lastly, hopefully we'll have some time for Q&A. And if you guys have some tools and strategies that you use for these things, I hope that you'll share them as well. So for the case studies, the first tool that we'll look at is a tool that I built called SnakeCam. I like to give kind of cool little names to these little toys that I build. This one is a tool that I use to run, to find and run functional and unit tests at work. And then I also wrote a tool called Windsock. Windsock is just a tool for sticking your finger in the air and saying which way the wind is blowing on a topic on Twitter. So we'll first take a quick look at SnakeCam. This came from a huge pain point that I have at work, and that's manually running unit and functional tests. How many people use nose to run tests? Okay, cool. How many people run your tests from the command line? Okay, how many people type out the whole name of the thing that you want to run when you run it from the command line? Okay, so you didn't raise your hand. Maybe at the end you can tell me what your strategy is for doing this. Cool. All right, so that's difficult to read. I apologize, but what we're looking at here is, so this is, these are some unit tests from Pyramid. Pyramid's a web framework that we use for several of our microservices at work. And so you'll have a test method, a parent class that test method belongs to, and then that will live in a module over here. So what does this look like if you want to run it from the command line without any tools to help you out? Well, you type nose tests, really long module name, colon, really long class name, dot, really long and specific test name. And you only need to do that a few dozen times before you try to find a better way to do that. For a while for me, that was some grep and awk-foo piped together to nose. That was kind of brittle and didn't work so well. So I dug into the man pages, and there is a plugin that you can use to tag each test with an ID. And that felt a little bit clunky, and now I've got to track all of these tests. It's not really what I'm looking for, so surely someone else has had this problem. In fact, they have 157 people, at least on Stack Overflow, have voted on this. But this is just what we already knew, which is type the whole thing out. Buried down at the very bottom of the answers was this guy. He had a really kind of cool solution. He defines this work in progress decorator, attaches it to a test, and then that's kind of similar to the first one. I thought that was clever, but still not exactly what I'm looking for. So what would be ideal here? I'd like to have a tool that I give some tokens from the test that I'd like to run. I'd like it to find that test and run it. I'd like to pass some options. Am I looking for a test method or a test class or a test module? And then I'd just like to pass whatever options I normally pass to no's as a comma-separated list here and have it run the tests and show me the output. So I built that thing, and I'll just give a quick demo. I'm not going to do a live demo just to save time, but we'll watch a video here and kind of go through it. So we're here in the pyramid unit tests. We're here in this test encode module. We're looking at this test Unicode val multiple test that takes some Unicode strings and checks that pyramid's going to URL encode them as we expect it to. And so we can go over to our shell here and invoke our tool and pass it some tokens from the test there. So Unicode val multiple, and it finds it straight away and runs it. So the whole goal here was to make life easier on ourselves. So it'd be nice if we could just pass it some partial tokens. So something like una and val, and it should still find the thing that we're looking for. It misses on the first time. I've not done any normalization or anything to account for length. So it's finding the shorter test name first. That's fine. If we tab through the results here, the next result that it finds, the second nearest neighbor. Seems like maybe there was something else I'm forgetting to say here. There it goes. And it runs those tests. So now maybe we want to run the parent class, so we can just invoke the tool again with the C option for class, URL inc, and it finds the class and runs them. And likewise with the module, the test encode module, just give it the M switch, and it will do what we expect there as well. So what's involved here? Well, I'm using argparse to grab the command line arguments. I've written some glue code to parse those arguments, set up the script, and run the tests. I'm using PyCLBR, which is a really cool, actually standard library module for doing some introspection to find the method names and the class names and the module names. I've got some glue code that will extract the test metadata from that. And then I'm using OS and Pickle to cache the data, cache some timestamps for the module files so that the next time we run this thing, we're only looking at the test files that have been modified since the last time we checked. I'm doing k-nearest neighbors with Dice Sorensen. I hope I'm pronouncing the second name correctly there. This looks Scandinavian, not sure about that. But it's just a distance measure that that basically takes the 2 times the most common the common tokens between your query point and your and one of your data points over the total number of tokens in both, and that gives you a distance, and then you're trying to find the distance that maximizes that value, and the distance that maximizes that value will be your nearest neighbor. And then I'm giving the results of that to sys and term color to display the results, and then I'm just spinning up a child process to actually run the tests and then display the test results. And that's pretty much it. So that's 8 imports and about 231 lines of code. We could probably trim that down a little bit, but we'll be kind to ourselves so that when we come back to maintain it in several months, we'll be able to understand it. So the next tool here is a tool called WinSock, and if you read the overview of what I was going to be talking about today, I actually said I was going to go through a Twitter tutorial. Instead, I thought, what better way to prepare for this talk than to try to throw together a tool I've wanted for a really long time over a weekend, which I did last weekend. So you'll get to see that today. But I do recommend you check out the tutorial if you're interested in this stuff. This guy is a guy from England named Marco Bonzanini. Again, I hope I'm pronouncing that right. I'll put all these links together, all the links that you'll see in the slides, and then a few others in a blog post, hopefully together with any links and tools that you have afterwards. So the tool that I wanted would be a tool to get data from Twitter for an arbitrary search term, process this data and store it. And then optionally for these next 2 things, I want to build it in kind of a modular way. So I've got some utilities that I can use anytime But then I've got a script, a directory of scripts for analysis and a directory of scripts for visualizations. I like to be able to pass as options to my tool the names of these scripts, and then for any data set that I load, I can tell it, run these analysis scripts and then run these visualization scripts on that data, and kind of set up a pipeline for processing this that's modular, and you can have pieces rearranged and things like that. And then lastly, it'd be nice to just have the thing spin up a web server to serve the visualizations locally if I've run a visualization script. So I built that thing too, and we'll take a quick look at that. Quick demo of that. So again, I apologize for the resolution here. It's poor planning on my part, but we'll invoke the tool here. I gave it Pluto as the search term. I'm filtering retweets there, so I only get source tweets. I'm looking for 5,000 tweets. I'll give it the freaks analysis script to do some term frequency analysis, and the freaks viz visualization scripts to visualize that, and the verbose option there as well. So this thing will go off and start gathering tweets. One of the reasons I chose Pluto is because it was trending. The other reason I chose Pluto is because it was the least likely to have horribly offensive stuff scrolling across the screen here, as anybody that's spending time on Twitter knows. Doesn't mean that there wasn't some in here, but anyway. So it's going to run our processing and visualization scripts, and then it's going to spin up a web server here, which we can go and check out. And then you'll get to see how much of a designer I am not. These visualizations are not very beautiful. It's kind of the out-of-the-box thing that I got with the library that I was using. But it's still pretty cool here. You see that we've gathered the most frequent terms for the tweets that we got. We've got moon, red, Quran, don't really know what that means, cap, new. Not really sure what's going on here. If we take a look at the, if we scroll down, we can see the most frequent bigrams. It's maybe a little bit more interesting. So now I'm making a leap here, and you wouldn't be able to make this leap if you didn't already know something about the data. Any statisticians in here are about to get offended, but it looks like maybe it's talking about the Quran is maybe a moon, and there's some dust, maybe some red dust and a red cap. So red cap and red dust may be connected somehow. Anyway, I thought this was pretty cool, getting this data and visualizing it this way. So even cooler than this actually was using a library called Vader to do a bit of sentiment analysis. So I did sentiment analysis on these terms. So again, not a designer, not great with visualizations, but what you're looking at here is for all of the tweets that appeared for the most frequent terms that we saw, this is where they fall from positive to negative score of 1 to -1 in terms of sentiment. And what you should see is fewer and fewer data points as we go to the right, because we had fewer and fewer terms. And I promise you that's what's actually there, but what's actually happening is that for some of these, you've got quite a few retweets that weren't actually retweets. I mean, they weren't tagged as retweets by Twitter. But maybe they had the exact same text and like a different URL shortened link or something in it, and so you've got these clusters of duplicates right on top of each other. Anyway, it did pretty well for this one positive term here. We'll take a look at this. This was the most positive thing I could find. Hope you have an amazing birthday. I love you to Pluto and back. Oh, thought that was sweet. Not really about Pluto, but that's pretty cool. Most of the rest of the examples that I have are cases where it didn't necessarily get it right. I thought that was both more interesting and also helps to drive home a point I'll make later during the pitfalls section of the talk. But one of the things it struggled with science-related tweets and with news-related tweets was things that were very neutral, that had some maybe negative phrases in them that it tagged as negative. So here it's saying that Pluto, moon, Quran's red head, tended by trapped gas, methane trapped by the chilly winter, night is slowly something. And I'm guessing that because maybe trapped was negative, it tagged it as negative here. But for things that maybe should have found neutral, it tended to struggle a little bit. Although if you go and you read the paper about this model and look at what the people that worked on this did, they accounted for lots of edge cases and had some really clever ways of doing that. Another place where it tended to struggle was with sarcasm and kind of thinly veiled insults. And since it's election season, we didn't have to look very far for that. There's plenty of that in the search term for Clinton here. This is 15,000 data points for searching for Clinton. And so a few places where it struggled with sarcasm was, we've got this tweet here. Thanks Clinton/Obama for giving Israel $38 billion instead of caring for the middle class. Yeah, it's obviously not a very positive tweet, but it thought that it was. Another place where it struggled here was everything about her head, but her head, brain, and memory. Clinton doctors declares her fit to serve as president. So a very mean-spirited tweet there that was flagged as positive. Next one here. I would love to volunteer if the Clinton campaign would actually return my web form submission. So some person who wanted to volunteer and never got called back. It did much better with overtly negative tweets. Here's a couple of examples. Powell reveals disgust with Trump, distaste for Clinton, and hacked emails. Another one for that same term, which was Powell here. Colin Powell describes Donald Trump as a national disgrace and reveals distaste for Hillary Clinton and hacked emails. So if you're wondering, we are actually a very positive community, so yay for us. Everybody is very, very kind here. The most negative tweet we had was somebody saying that they were ashamed to say that I'm using evil MATLAB for this project. On my benchmark, chunking and deflate level did very little. Sorry to hear that. The most positive tweet we had, I think, might have been about Sarah Bird's talk yesterday about bokeh. Makes the creation of rich and visually pleasing interactive figures simple and fun. I hate that I missed that. I was preparing for this talk. I'm really looking forward to catching it on YouTube. I heard that it was a really great talk. So that's WinSock, or that's one thing you can do with WinSock. I'm not going to go through this stuff in detail for the sake of time, and also because I think most of us in here can go ahead and abstract from this what's going on, right? We're taking the difficult stuff and doing it with a library, and then we're writing a little bit of glue code to marshal data and piece these things together. I will say, if you have time, be sure to check out Vader, or at least NLTK's implementation of it. To the point of this talk, it's super simple to get started with on toy data sets. You can pull something in, you literally pass a string to a function and get polarity scores for sentiment analysis. Also, check out Plotly if you haven't already. It's kind of doing one of the tools, which is trying to do for visualizations what Jupyter Notebooks have done for having an interactive REPL and a kind of a GUI environment that you can share with others. Vincent is also very cool. I believe this project is defunct, or at least no longer maintained. It now points at Altair. Both of these tools, Altair and Vincent, provide bindings onto D3.js, so you can build up your data structures in Python and then have that create some JSON that D3.js visualization can consume. So this is 21 imports, either standard library imports or external libraries, and about 600 lines of code. And it took a weekend and I think 2 or 3 weekday nights to kind of clean things up. So it's kind of a toy, but a pretty powerful one that was a lot of fun to build. So we're taking all these different libraries, 21 in this case, and we're piecing them together. We need some tools and strategies for doing that. So the primary needs that we have here are a way to get and install libraries, a way to manage libraries across projects, a way to interactively explore APIs, and a way to view and affect state during execution. So there's a few slides here. I think for most people here, it's going to be pretty basic stuff. But for our online audience, this talk does target novices, so I'm going to cover some basics here before we move into detail about the tools. So for getting and installing libraries and packages, you can imagine your machine here. You've got your system Python installation. You've got a place where you can put packages where Python will know about it, and if you run a program on your machine in Python, it can find those libraries and use them. And then you've got PyPI, or the PyPackage index, that knows about libraries and packages and has them there. And then you've got a package on your machine that's job is to go out and find packages and install them in a place here where Python knows about them. So Pip is the tool that I use for that. I think it's the tool that most people use these days strictly for Python dependencies. And you can read about that here if you're not familiar with it already. So let's talk quickly about virtual environments. Imagine that you're setting up a new blog, and that blog requires Django 1.10. And so you install that, and you run that under System Python, which has Django installed as a package and knows about it, and your blog runs great, and you're happy. But then a few months later, you decide that you want to contribute to this open source project that you found out about, and they require Django 1.8. So now what? Virtual environments give us an easy solution to this. We reserve System Python and its packages for tools that we use system-wide. And then we've got a virtual environment with its own Python interpreter for our Django blog running 1.10. And we've got another virtual environment with Django 1.8. So if you're, the tools that I use for this are virtualenv and virtualenv wrapper. But if you're new to programming, if you're new to Python, I highly recommend you check out a tool called Conda. It's here. It manages Python packages and virtual environments. It also manages dependencies that are outside of Python, importantly. So interactively exploring APIs and debugging. I use the IPython shell for that. And I use PUDB as a way to kind of view an effect state as my program is executing. So I use PUDB as my debugger. I'm partial to command line utilities. I kind of live there. I spend most of my time there. I work on backend APIs, so there's very little interface work in what I do anyway. But if you're partial to GUI alternatives, or if that's kind of what you feel more comfortable with, of course, Jupyter Notebook offers a kind of heavily augmented IPython shell in the browser that you can then share the output of your work with others. And then PyCharm offers a very powerful GUI debugger as well. So I've got this kind of little contrived example for us to step through some code together, generating randomly colored outfits. So if we start with this white outfit here, that's kind of boring, and we might want to impress our front-end designer friends by adding some color to our outfit. So we might add something like light salmon as our shirt color, and pale violet red as our pants color. And yes, these are CSS3 color names that your browser will respect. So if we were actually going to do this, then of course we would just have a list of color names, and we take a random index into it, and job done, right? It's probably 2 or 3 lines of Python. But for the sake of a contrived example, let's imagine that we couldn't do it that way, and we needed to tie some libraries together. Went out and found some for this. Random color, web colors, and SciPy are the libraries that ended up tying together. So I kind of intentionally started with this with like something really absurd, and I was like, I'm going to find a way to tie some tools together and make this happen, and went and did it. So random color gives us a random value from 16 million plus possible colors. Web colors knows about and has mappings for 147 color values to CSS color names. So immediately we have our first problem of incompatibility here. Again, ridiculous example, but consider the general case, right? Where you've got 2 completely different things that need to talk to each other, and you've got to find out a bridge or a way to make that happen. So the way that I thought we could make that happen is to take one of these colors and find its nearest neighbor in the set of web colors that are available here. And so to do that, we've got to write a bit of glue code. We've got to convert the CSS string that we get from random colors. So it gives RGB values in this kind of string RGB parentheses and then the integer values there that random color gives us into a common format that both web colors and SciPy can consume. And then we've got to use web colors to create a RGB value to color name mapping. So we've got some data structures for looking up nearest neighbor RGB values, and also a data structure of all the RGB values that exist in web colors to instantiate our k-dimensional tree with. So we'll go through this together. I may have to cut this a bit short because I want to make sure we get time for questions and also pitfalls. And this is 8 minutes, so we're not going to make it. But we'll go through the really important parts here at the beginning, and then if you'd like to see the full implementation or dig through the code together, you can find me afterwards. So it starts out like this. Tells us we should wear white pants and white shirt. Very boring. We're going to try to change that. So we'll set up a virtual environment, install our tools here, random color and web colors. And we will install IPython. We'll open up an IPython shell, and we'll pull in our libraries here, random color and web colors. And then from there, we can start exploring these APIs. So let's look at random color first. And we get a nice drop-down list with a tab completion after the dot there. Random color looks classy, as in it's probably a class since it's camel-cased. So if we give it a question mark and hit enter, we'll get the docstring, which this library sadly doesn't have, and definition for the init there. And if we look at that definition, we see we don't really need much to instantiate this. In fact, we don't strictly need anything, so we can just create an instance. And now we can explore that instance the same way, just dot, and we get a nice little tab completion of the properties that are on this instance. Generate looks really promising because what we'd like to do is generate a random color. So let's look at the docstring and the signature for that. Again, no docstring, but if we look at the keyword parameters here, it looks like we can specify a format. So we got a format of hex there. And we can look at the source of generate here by using get source from the inspect library, and we see that at the very end here it calls the set format method, which we can then view the source of that. And if we look through this, we'll see that it looks like it takes HSV, RGB, hex, and so now if we call it and we pass it a format of RGB, which are the kinds of values that we'll need for our KD tree, we see that we get one. But again, it's this list with a CSS string, so we'll jot that down in our little scratch pad here for that's the kind of data that we're getting out of this library. I'm actually going to cut it short there because we've kind of seen what we can do with PUDB. I'm going to fast forward through some of the stuff here. Imagine we've hit a problem now and we need to inspect our data as it's executing. This is what the debugger looks like. So you just set a breakpoint here, and then after that you can step through your code, step into this method here. If I want to see the variables that are in scope, I can look over here and get that data there. And then what's really powerful about this is that from inside of PUDB, you can actually drop down into a IPython shell with all of the context and the environment that exists for your program as it's running. So this is super powerful. Now you're in IPython, you've got all your IPython tools available to you with all of the data. You can review a docstring here if you've forgotten how something works. And then for the big reveal, sorry we didn't have time for the whole thing. Yay. We've got lots of different outfits. We run it a few more times. We've got a whole week worth of clothes. So really convoluted and around your elbow way to do this, but illustrative of the point, hopefully. So my approach for attacking a problem is typically to find relevant packages. First split your problem up into the specific things that you need to do to solve it. Find some relevant packages that do those things, and then immediately skim through the documentation and then look through the Stack Overflow questions and check for open issues on GitHub. See if there's any gotchas that you need to be aware of, or is this thing even still maintained? Especially if you've got two tools that are known to work together, make sure that there's no open issues between the two. And then set up a virtual environment, install the packages, and then I'll bomb around in the IPython shell, kind of interactively explore the API, look through the source code, look through the doc strings, and start looking for points of integration between the libraries that I've pulled in. And then I'll make a really simple proof of concept, something, just the dumbest possible quick implementation, brute force, minimum viable script. And what I'm really doing here is gathering context, right? I'm familiarizing myself with the surface of the problem. And then from that context, I would step back, think about, and research the problem using all this new context I've gathered and being mindful of some important pitfalls, which I'll step into next. So if we look at the pitfalls, this first one is a kind of personal problem that I think many developers struggle with, and it's this idea of the Dunning-Kruger imposter syndrome cycle. So who's familiar with these two things? Okay. So Dunning-Kruger effect is kind of illusory superiority, self-assessing your abilities to be much, much higher than they actually are. So it's kind of thinking you're better than you actually are. Imposter syndrome is the inability to internalize accomplishments and worry of being exposed as a fraud. So one of these is thinking that you're much better than you are. The other is thinking that you're maybe much worse than you are. And this comes up a lot when you build something really cool really quickly, because you immediately think like, oh man, I'm amazing. I built this really cool tool that does this cool thing. But then you realize like, well, I'm actually just taking stuff that other people wrote and kind of jamming it together. And you end up kind of going between these two things. The really funny thing here is that mistaken self-identification with one kind of implies the other. So you can kind of end up in this weird recursive kind of loop, trying to figure out which one you are. Untangling that mess maybe gives a penetrating and liberating insight into the ultimate nature of things or something. I don't know, but like a Buddhist koan or something. But anyway, so you're pretty much fine unless you do this. You know, from NLTK sentiment, import Vader, instantiate our sentiment intensity analyzer. You're a dumb, smelly jerk, get some sentiment scores, and then later that night at a party, don't be that person, right? Remember what it is you've accomplished, but at the same time, don't dismiss it out of hand, right? There's a lot of context that you had to gather. There's a lot of background, a lot of knowledge that you had to have to kind of gather these tools, know the right ones to use, and find ways to fit them together. So don't be overly boastful, but also don't dismiss your accomplishments. Next is the thing you're looking for may be right in front of you. So Stack Overflow is not a panacea. You know, I use Stack Overflow all the time, don't get me wrong. But, you know, as soon as you hit a wall, don't immediately go and grab something from there and start, you know, pasting it into your code. And then if it doesn't work, like, oh, I couldn't figure it out. Don't be afraid of the documentation. The thing that you're looking for is probably right there in the docs somewhere. It may just be that you haven't got the context that you need or the term that you need to search for to find that thing. So what you need to do is play with the problem more, explore the source code a little bit more, find some terms, find some Google fodder, find some documentation search fodder, and then go back and attack your problem with some tenacity. And so for me, this is skim the docs first, explore ruthlessly to develop context, proof of concept, and then go back kind of to the beginning, better informed and ready to kind of dig a bit deeper. So next, fork kickass is a thing, not a blueprint. So this is fork kickass for any Archer fans. It's Krieger, he's kind of the mad scientist there. And fork kickass is awesome, but probably not effective against heavy infantry. And so this is just kind of talking about being aware of overfit and the fact that when you kind of throw something together quickly, even if you think it's really modular and like, oh, if we needed a door, it's so modular, we could just move these boxes and then we'll have a door. Yes, but if a tank comes through, you're probably in trouble, right? So you've built this thing, it's really cool, but just be, you know, before you start throwing it out in meetings at the office, or you start trying to think that you're going to solve these really big, challenging problems with this toy that you built, just keep in mind that you've kind of thrown something together quickly, and the likelihood that it's going to generalize for the general case is very slim without a lot of extra effort. Remember that library developers are human also. Library exists is not equal to problem solved, so do not think like, oh, it's a couple of lines of Python, right? There's a library for that. So I'll start on Monday, I should be done by Wednesday. Might take longer than that. Expect a few non-trivial setbacks and lots of bumps in the road. Apply Hofstetler's law and then add time. Hofstetler's law is that it's always going to take longer than you think it's going to, even when you apply Hofstetler's law. So, you know, apply the law and then add some time, still won't be enough. And then finally, this may be the most important point of the talk, develop strategies for discovering blind spots and dealing with rabbit holes. There's no magic bullet for this, but with time and experience, you'll develop the heuristics you need to not have typos like time and experience in your talk. Sorry. Some heuristics will emerge for finding your blind spots. If you're new, if you need something concrete, if you're new, be mindful of striking a balance between not investigating enough and getting stuck in a local minima. So concretely, here's what I try to do for this is feel the overwhelming uncertainty and apparent kind of vastness of the problem and just be okay with it. And this is maybe the most important thing that any of us have to do when we start working on a problem, right? Because as soon as you're comfortable with a problem, that means that you understand it and you've solved it. So we live here, and we need to kind of be comfortable with that. And then I strike out, explore, and play, and develop the context, as we discussed. And so I've kind of got this little heuristic. If my brain key errors on any concept or term 3 times, that merits a note to self. And that might be a mental note if it's something that I think I can track, or I might use quick add in Todoist or jot something down on a piece of paper that I need to look into this later. And this is kind of my strategy for not getting stuck in kind of local problems that may be obviated once I've solved for the actual problem that I'm after, right? And then I'll get my dumb, fast, easy solution. And then at that time, when I'm doing that review that we talked about, right, when I'm going back and thinking about the problem more deeply with this additional context, that's when I'll review these kind of little local problems. I'll see, are these things still relevant, or kind of did I sort this out by figuring out this other bigger problem? So with that, I'll say it's a magical world. I wish you all the best in exploring Python and finding ways to build cool new things with this. That's it.
Thank you, Rob. We have 4.5 minutes for questions.
Awesome. That's perfect. That's exactly what I wanted.
So it's a great talk, Rob. I just wanted to kind of add a little advice I use when I'm doing that exploring phase of like downloading new packages and trying them out is, developing a new repository or directory. And one of the first things I put in there is a requirements.txt file, and actually write down the names of the packages I've downloaded and installed, and then you can actually use that and do a pip install with one command to install everything that's in that file.
Absolutely. Cool. One thing I was hoping for was to get some suggestions for tools or strategies or approaches that you guys use. So if anybody has any that they'd like to share, that would be great.
PyTest over
PyTest?
nose.
What's that?
PyTest instead of nose.
Okay.
I don't think that nose is still under active development. And
wow, okay.
PyTest is a complete superset, and you can basically take your nose tests and just run PyTest instead.
Oh, nice.
Yeah.
Okay.
So
Cool.
yeah.
Nice.
Yeah.
Very cool.
Not a question or a suggestion, but I think you will be posting a lot of these tools. You're going to be building a list, and you said if there were some contributions, what's the mechanism to, if we want to send you some links or something?
Yeah, so there's, you can ping me on email at either of these addresses. This is my work address and then my personal address there. On Twitter. Either of those would work. Once I am out of the proof of concept stage with these tools, I'll hopefully be putting them up on GitHub, and then you could just submit PRs there. But yeah, feel free to send me an email, or if you'd just like to kind of like take a look at some of the code and like talk about some of this stuff in more detail, or see like the full demo of the example, little toy example outfit color picker application, you can find me in the halls afterwards, and we can look at that together. Any questions? Yeah, sorry.
Not a question, just something that I learned and just something that I would like to share. So when we depend on a lot of different libraries, one thing to note is that not all libraries have a huge developer base. Many of the libraries, and particularly the more obscure ones, have just about 1 or 2 people working on them, and it's always a good idea to support the developer, either by adding some code to it or by providing some monetary support to it. So
Absolutely.
You can see sometimes there are some features that you see that it's in the changelog or it's in the comments saying that this is right now in the beta, it's going to be merged to the branch, but that has been like sitting there for so many months because the person simply has lost his motivation to do that.
Right, or they're super busy. Or
right, exactly.
Yeah.
So it's always a good idea to support the developers. Open source is a great thing, and if that's always a great one way or other, support the developers so that we can have more and more libraries like this.
Absolutely. Is GitTip still a thing? That's something I kind of participated in when it was first announced. Anybody familiar with GitTip? Has it? So GitTip was a way that you could kind of tip open source developers and support them for their projects. To your point, right? I'm not sure what it's called now. I kind of had forgotten about it until just now, but absolutely great advice. Thanks. Sorry.
Oh, go ahead.
I was just going to say, if there's any last questions, we've got maybe 30 seconds. We've got time for maybe one last quick question. Anybody has one? Yep. Grant to pay.
The name of Git tip is now Gratipay, Gratipay.
Gratipay. Okay, cool.
Yes, I was just wondering, when you're doing your quick and dirty proof of concept, do you flesh that out enough to run it under PUDB all the time, or do you use something also a little quick and dirty like embed from IPython?
So a lot of times what I'll do is I'll kind of build up a kind of quick and dirty method in IPython, and then just move that over to, because I work in tmux usually, so I've usually got IPython running right here with Vim. And so I'll build up something in IPython, and then I can just visually select that, yank it over to Vim, and then maybe flesh out a little bit more, and then stick in a breakpoint, and then work through it in PUDB. That's usually my workflow. How about you? What do you usually do for that?
When I'm doing the proof of concepts and whatnot, if I have something in any kind of runnable state, if I'm just tinkering with it, I'll copy, paste, or whatever into a shell directly. But if I have something runnable and I want to check it out, and I don't feel like setting it up under some other type of debugger process, I'll just import IPython, import embed from IPython, and call it
Embed?
Yeah, it's from IPython import embed, and then just call it embed as a function. Pop, puts you right in an IPython shell, right in the middle of your execution.
Oh, nice. Okay.
It's probably
Great.
what PUDB
That's
is
probably
using
what PUDB
anyway.
uses under the. Yeah, exactly. Yeah. Interesting.
All right. We should thank Rob for an awesome talk. Thanks.
Thanks, guys.